Okay, Math 7, we are going to section 3.3, and this is multiplying decimals. So if we look here, our objective is to multiply decimals. The first few, we are multiplying decimals by integers. That means that one of the numbers is not a decimal. It's kind of a whole number, but it can be positive or negative. And then the second three examples, we have 2 decimals. So these are going to be a little bit different than adding or subtracting. So the little fun fact or the note that I'm going to have you make here is that when multiplying, you do not line up the decimals. You ignore them until the end of the problem. Okay, so what that means is that I have 2 numbers and it's 6 times 0.1. I like to pick the one that has the most digits on top, or yeah, the most digits on top. So I would do something like this. Okay, maybe I'll put that little put. I put the number with the most digits on top. Okay, so then this problem, we're just going to multiply like normal. So 6 times 1 is 6. 6 times 0 is 0. I have 1 decimal point in my multiplication problem, so I move 1 decimal point. Move left for each decimal place in the problem. Okay, so the decimal was kind of out here. You put it right there. So your answer is 0.6. Make more sense when we do a couple more. So again, I have -2 times 0.04. I put the one with the most digits on the top. Put the 2 down here. I line them up. I ignore the decimal, and I'm just going to do my multiplication. 4 times 2 is 8. 2 times 0 is 0. 2 times 0 is 0. How many decimals do I have? I have 2 decimals. So that means I'm going to move 2 places from here. 1, 2. So it's 0.08. Now there is a negative, so a negative times a positive is a negative. Okay, our next one, I have 1.25 times 23. There's more digits in the 1.25, so that one goes on top. We align them on the right-hand side just like we do with regular multiplication. And then I multiply like normal. Well, we have more digits here, but we can do that. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. Then do your next row, and that would be 2 times 5, which is 10. Remember to move over 1 spot. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. Then we're going to add them. This is all kind of normal stuff that you guys do. 5 and nothing is 5. 7 and nothing is 7. 3 and 5 is 8. And nothing and 2 is 2. How many decimal places do we have in our problem? Well, there are 2 in here. 2 places. So I move 1, 2. So our answer is 28.75. So 2 decimals, 2 places, 2 decimals, 2 places, 1 decimal, 1 place. But I don't do anything till the end of my problem. Okay, so now we're going to do 2 decimals, not just a decimal and a whole number. These two have the same number of digits, does not matter which one you put on top. I'm just going to go in order, 1.2 times 1.6. So in my head, I'm kind of treating this like 12 times 16. 6 times 2 is 12. 6 times 1 is 6 plus 1 is 7. 1 times 1 is 2. 1 times 1 is 1. 2, 7, 8, 9, and 1. Now, you have to count how many decimals there are total. So there's 1 decimal place here, 1 decimal place here, or you can think of them here. So I move 2, 1, 2. There's your decimal. So it's 1.92. Okay, same thing. This is a negative times a negative. I can evaluate that now or wait till later. I'm just going to focus on the multiplying right now. Again, it's kind of like taking 24 times 18. 8 times 4 is 32. 8 times 2 is 16, plus 3 is 19. 1 and 4 is 4. I moved over 1. 1 and 2 is 2. I'm going to add. It's kind of fade into my next problem here. 2, 9 and 4 is 13. 2, 3, 4. Okay. How many decimal places do I have? Well, I have 1 here and 1 here. So I move 2. So it's 4.32. It is a negative times a negative, which would give us a positive. Okay, last one here. I have 3.84 times 0.9. The one with the most digits is the one I put on top. Nine times 4 is 36. 9 times 8 is 72. 72, 73, 74, 75. 9 times 3 is 27, and 27 plus 7 is 34. You don't have to multiply by that 0, since zeros won't really do anything. We just have to make sure we have enough decimal places to move. And we have 1 here and 2 there, so that means we're moving 3. 1, 2, 3. So our answer is 3.456. A negative times a positive will give me a negative. Okay, and then using estimation to check is a great way to see if these are accurate. I'll just give you one little example here. I'll do a couple maybe, especially with these decimals. If I did check with estimation. Okay, we're going to round to nice whole numbers. So 1.2 would round to 1. 1.6 would round to 2. What's 1 times 2 is 2. Is our answer pretty close to 2? And it is. The next one, 2.4 would round to a negative 2, and a 1.8 would round to a negative 2. What's negative 2 times negative 2? Positive 4. 4.32 kind of shows us that we put the decimal in the right spot. Last one, I have negative 3.84, so that would round to a negative 4, and 0.9 would round to a 1. Negative 4 times 1 would give you a negative 4, and we are pretty close. It's at negative 3, but again, it's rounding, and at least that's not 34. That would really tell us that we did something wrong. So checking with estimation is a great tool to see that you guys have your decimal points in the right place.